Good evening, everyone. This is your first flipped lesson for the month of December, December 1st. Now, guys, I know Christmas is coming up quick. We got a lot of work to do, like I've talked about in class. A lot of work to do, and then we'll take it easy. And remember, your only homework over break will be to watch a couple review videos, all right? They'll help you review Chapter 5, Chapter 6, that kind of stuff. But keep working hard. I'm proud of the effort you guys are doing. Now, last night's video helped you practice with fractions, and then today in class we practiced with fractions a little more and then stuck them into equations. Now I'm going to throw a worksheet back at you that first period was already assigned and third period had it postponed because I realized after first period, we kind of crashed and burned. They really didn't know how to do them. So we're going to come back and revisit that here on this video, and then tomorrow in class, you'll have a chance to practice some of these. So let's take a look at a couple problems from worksheet 6.2 multi-step inequalities. And I will run through how to solve them and then also how to graph them. All right, so let's look at this problem here. Negative 4/5 t plus 3 is greater than t minus 2. Now, this is a pretty easy problem. It freaks some of you out because it's got a fraction in it. You have a couple options. One, you can start by getting all your t's on one side. That's a good way to do this problem. Two, you could get rid of either the 3 or the negative 2. That's another good way to do the problem. 3, you could multiply to get rid of your fractions, but you have to be careful because when you multiply to get rid of fractions, you're going to have to do it in 4 places. 1, 2, 3, and 4. I think for this video, I'm going to go ahead and I'm going to use as many fractions as possible because I need you guys getting more comfortable with them. So I am going to start by getting all my t's on one side and all my non-t's on the other. I like my t's positive normally, but I'm going to go ahead and let them be negative so that you can remember what happens when we multiply or divide by negative. So my first step will be to subtract t from both sides. This will move all my t's to the left. And you know what? I'm going to double step here. I hope you don't mind. I'm going to subtract 3 from the left-hand side, and that will move all my constants, my non-t's, my regular numbers, over to the right-hand side. So when I do this, and it's just a double step, all I've done is done 2 steps in one. If you don't like that, then the red part of the problem is the first step. Do that, simplify your equation, and then do the blue step. But that's all I've done is combine them in the same line. Okay, I know these are going to cancel. I know those are going to cancel. I'm going to be left with a negative 5 over here on the right. And by the way, guys, you can't be getting this wrong. You have to know that's negative 5 on site. You're honors algebra kids. If you don't know how, come in and I will help you with it. But you have to know that negative 2 minus 3 is negative 5. You can't guess and get that wrong. You can't run to your calculator. You're honors algebra kids. Okay, my pre-algebra kids are learning to do this just by looking at it. They're not quite there yet. You guys should already be there. All right, now I have a negative 4/5 t and a negative 1 t. Well, that's a negative 1 and 4/5 t, right? But man, working with mixed numbers can be difficult, so I'm going to go ahead and convert this into an improper fraction. And again, this is something I already expect you to know how to do. If you don't, you come in and you get some help. But don't just sit there and go, oh, I'll use my calculator. Your honors algebra. I mean, I have to make evaluations for you pretty soon. I think it's in January. And I have to recommend if you're going to stay in honors or not. If you can't do basic fractions without a calculator, I won't be recommending you for honors. Okay, so just to explain, I'm going to do 5 times 1. And then I'm going to add the 4 to it. I'm going to ignore the negative. It'll screw up my math if I try to put it in there. But I'll keep it and add it on at the end. So 5 times 1 is 5, plus 4 is 9. That must be 9/5 t, and it's negative. All right, that's greater than negative 5. Now, again, I could multiply by a 5 here, but I'm actually going to divide by the fraction because a lot of you have trouble with it. The more you see it, the more comfortable you'll get with it. You have to know how to divide by fractions. Well, the negative 9/5 t is attached by multiplication, so I will divide by a negative 9/5, on both sides. Okay? I just divided by a negative. What is going to happen to my inequality? It's going to flip. The less than will, excuse me, the greater than will become a less than. All right, the easy side is, boom, I just get t, right? This side becomes negative 5 over 1 times negative 5/9. Remember, dividing by a fraction is the same as multiplying by its reciprocal. Some people call that a copy times flip. You copy this, and I wrote it as a fraction because I'm dealing with fractions. I changed the division to multiplication, and then I flip my fraction. I use the reciprocal. All right, so now I have t is less than. Nothing here is going to simplify, so I'm going to multiply negative 5 times negative 5 to get positive 25. I'll put that over 9. Now, that answer really doesn't make sense in terms of a graph to me, so I'm going to convert that back to a mixed number. 9 goes into 25 2 times. Let me see, that 2 times 9 would be 18. 18 and 7 would be 25, so I must be 7 short of 25, so it's 2 and 7/9. So the simplest answer would be t is less than 2 and 7/9. And I know approximately where that is on a number line. I know approximately where that is. 2 and 7/9 is pretty close to 3, a little bit farther from 2. I know it's going to be an open circle, and now I need numbers that make this a true statement. Give me a t that makes that true. Well, pick an easy one, like 0. 0 would make it true, wouldn't it? 0 is less than 2 and 7/9? Of course it is. So that means I have to shade towards 0. I don't know if a teacher ever said, well, you know, if the less than's pointing this way, or you should. No, don't do that. Use the inequality, pick a value for t that makes it true. If you pick a value that makes it false, like say 10, well, notice there's no shading that way. There's no shading towards 10. Okay, very good. Let's try one that's a little bit uglier. Okay, this is problem number 7 from that worksheet I was talking about. To do this one, you know, you could get them all to have the same denominator of 12. But to me, that's the hard way to do this. I would rather make my fractions go away. So what I'm going to do is I'm going to list, excuse me, multiples of the largest denominator, 12, and I'm going to keep listing them until I get a number that 6 will divide into evenly and 3 will divide into evenly. So the least common multiple. So 12. Oh, look at that. 6 goes into 12, doesn't it? 3 goes into 12. Oh, I don't even have to go to the next multiple of 12. 12 is the key number here for me in this problem. What I'm going to do is I'm going to multiply each fraction by some form of 12. 12 over 1 times 12 over 1 times 12 over 1. Okay? Now, the middle fraction is probably the easiest one to see. 12 divided by 12 turns into negative 5, right? Now, over here on this fraction, I know that 12 divided by 6 is 2. That 2 is in the numerator. Why? Because the 12 is in the numerator. Look, every single one of you knows that 12 over 2, not 12 over 6, 12 over 2 is the same as 6 over 1. Where's that 6? Where's that 6? Oh, actually, I was doing that wrong, but that's okay. That 6 is in the numerator, right? So if I did it with our current problem, sorry, I'm confusing myself, guys. 12 over 6, we all know that's 2 over 1. Where's the 2? It's in the numerator. It's in the numerator. So my 2 is upstairs in the numerator. I like saying numerator. Well, somebody once told me that it was Latin for the number 8er, but I realized quickly that that was not right. All right, so if I had 6 over 12, well, that simplifies to 1/2. Where's the 2? It's in the denominator, right? Okay, hopefully you're getting that now. So let me get rid of this little sidebar here. And I am done simplifying, so now I simply multiply. 2 times n, 2n. 1 times 1 is 1, simplifies to 2n. All right, I'm going to keep that inequality. I did not multiply by a negative, so my inequality did not flip. Now over here, I'm going to simplify diagonally. 3 goes into 3 once, it goes into 12 4 times. 2 times 4 is 8, and there's an n there, 8 times n. Now, it's a pretty simple equation. Now, if you're a person that has to have your variables on the left-hand side, this is a harder problem. If you can get comfortable with the fact that I can subtract 2n here and subtract 2n over there, and then get negative 5 is greater than or equal to 6n, right? Almost done. I'll divide each side by 6, and therefore I get negative 5/6 is greater than or equal to n. On a number line, that might look something like this. I know that negative 5/6 is going to be pretty darn close to negative 1, a little bit farther from 0. Okay, I know my circle is going to be closed. Why? Because it says equals, right? If I say the word equals, it's a closed circle. And I know numbers that make this true. Negative 5/6 is greater than what numbers? Well, using the numbers on here already, is negative 5/6 greater than 0? Of course it's not. Is it greater than negative 1? Absolutely. Negative 1 makes this statement true. Well, I wrote negative 7, but that makes it true also. I'll shade in that direction. All right. There we go. There we go. All right. So, I'm trying to see if there's an uglier one on here. I think I'm going to leave it at that. Hopefully you're getting better at these. Friday, we'll go ahead and get a little more practice. Then I would expect a quiz on Monday over solving inequalities and graphing them. Remember, there is help after school Friday. All right, Mr. Lawrence signing off.